This lesson is about balancing redox reactions using the bridge method from Wiley's section 14-2. What we'll do is we'll balance simple redox reactions using the bridge or oxidation state method. We'll show you the steps to use this method and we'll work some examples. So back in Chem 1, we balanced chemical reactions. The purpose for balancing chemical reactions is we had to follow the law of conservation of matter. The arrow in a chemical reaction, it's just like an equal sign. And we balance the reactions because we have to have the same number of the same element on both sides. It's like a math equation. Balancing redox reactions now, it's similar, but it's more involved, it's more complex than just balancing equations for the atoms. In a redox reaction, one reactant gains electrons and the other reactant loses them. So the purpose of balancing redox reactions is not only to balance the atoms, but we have to balance the electrons as well. Redox reactions are all about electrons. So the first thing we need to do is identify which elements gain electrons and which element loses electrons. We do that by identifying the oxidation numbers for each atom in the reactant and the product side. If the oxidation number changes as an atom goes from reactant to product, we know that atom has gained or lost electrons. So let's do an example. We have solid copper plus zinc 2 plus goes to copper 2 plus plus solid zinc. So this occurs because electrons are transferred. Just as a side note, there are spectator ions in this reaction that go with the zinc 2 plus or the copper 2 plus. It might be chloride, it might be sulfate. Those are not written, they're not important to balancing, but just so you know that there are other species there. So we're going to identify the oxidation numbers for the reactants and products. Now if you've forgotten how to do that, please review section 14-1. There's also a video that covers that as well. If you don't know how to identify oxidation numbers, balancing these reactions will be quite challenging. There's our reaction. So copper's oxidation number goes from 0 in the reactant side to 2 plus in the products. Zinc goes from 2 plus to 0. We'll assign those oxidation numbers. Okay, here's the bridge part. This is why they call it the bridge method. Copper goes from 0 to 2 plus because it loses 2 electrons. We're going to draw a line connecting solid copper in the reactant side to copper 2 plus in the products. Okay, there's our line, there's our bridge. We go from copper 0 to copper 2 plus by losing 2 electrons. So on my bridge I'm going to put minus 2 electrons. That E minus symbol means an electron because electrons are negatively charged. Let's do the same thing for zinc. It goes from 2 plus to 0 because it gains 2 electrons. We'll draw our line, say plus 2 electrons because zinc 2 plus gains, and there are our bridges. Now let's look at our electrons. Copper loses 2 electrons, zinc gains 2 electrons. They cancel. Our equation is balanced. We're done. This is a very simple example. So the balanced equation is boom, just right as given. Now, this is a good example for showing how the bridge method works, but there are other examples that are not so simple. Let's do another one. And this problem actually is from Wiley. So the instructions are: balance the equation, do not cancel compounds on both sides of the equation even if possible, and it also says note the coefficients provided may be wrong. In addition to working this problem out, I want to give you some hints to make this problem easier to work. There's our given reaction. So I don't know why Wiley says don't cancel species on the opposite sides even if they're the same, because in this case zinc solid is not the same as zinc 2+. You don't want to cancel those regardless, so I would just kind of ignore that statement. Also, when solving these problems, you're going to be placing coefficients anyway, so the given coefficients are distracting. I would just remove all of them. So if you're given this problem with the 4 and the 2 and the 2 and the 3, just remove those. Here's the equation we want to balance. So first we're going to assign oxidation numbers. Zinc has 0. In the reactant side, zinc 2+ has a +2 oxidation number. Gold 3+ has an oxidation number of, wait for it, 3+. Solid gold, of course, oxidation number of 0. Now we're going to place our bridges. We know zinc goes from 0 to 2+, gold goes from 3+ to 0. Zinc loses 2 electrons, gold 3+ gains 3. There's our zinc bridge, there's our gold bridge. Now, the whole reason we're here, we want to cancel electrons. As written, those electrons do not cancel. So we've got to manipulate the coefficients to make sure our electrons cancel. So what do? We want to get the same number of electrons lost and gained. The zinc bridge will multiply by 3. That includes the reactants, the products, and the number of electrons. The gold bridge gets multiplied by 2. Here's our equation now after multiplying the zinc by 3, the gold by 2. We have our coefficients. Now our electrons cancel. And this is our balanced reaction. We've got the same number of zincs on both sides, zinc solid, zinc 2+. We've got the same number of golds on both sides, 2 gold 3+, 2 gold solid, and the electrons cancel. There is our balanced redox reaction. So this lesson demonstrated how to use the bridge method for balancing redox reactions. Remember, electrons are the key. Practice the assigned Wiley problems, and of course contact one of your course mentors if you have any questions. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.